All right, let's jump right into this explainer put together specially for all of you students at CM Shri in a Colony. Today, we're going to uncover the immense, kind of hidden forces that are literally creating and destroying the world around us. We step outside, look at a mountain or a river, and just assume, well, that's always been there. But as we're about to see, the Earth, it is a highly active, incredibly dynamic machine.
When you look at a classroom globe, you probably think the Earth is completely still. I mean, it feels solid, right? The ground doesn't exactly feel like it's in motion. But today, we are going to completely flip that perception on its head.
I want you to ask yourself this exact question right now. Is the ground beneath your school, CM Shria in a Colony, actually moving right this second? Just keep that thought in the back of your mind, because by the time we wrap up, the answer is going to completely change how you view the very ground beneath your feet.
Here is the roadmap for our inside-out journey today. 1. The Earth's hidden engine. 2. Tectonic plates in action. 3. Nature's slow sculptors. 4. Agents of gradation. And 5. Humans and the land. Let's get to it.
Section 1. The Earth's hidden engine. Let's look at the layers beneath our feet.
So think of the Earth kind of like a cracked eggshell riding on top of extremely hot, thick soup. You've got the crust on the very outside, which is surprisingly thin, only about 5 to 40 kilometers thick. Below that is the mantle, which is this enormous, incredibly thick and hot layer. Then we hit the outer core, a fluid layer of iron and nickel, and finally, the inner core, which is literally a solid, spinning metal ball that's unimaginably hot.
Now, for those of you taking notes, and you definitely should for your exams, write this down: the lithosphere. This is the rigid outer layer of the Earth. It includes the crust and the very top part of the mantle. But here's the kicker. It isn't one solid piece. Actually, it's broken up into these massive, puzzle-like pieces that we call tectonic plates.
And right below that rigid lithosphere, that's the asthenosphere. This is a hot, semi-molten layer of rock. And because it's somewhat fluid and mobile, it actually allows those gigantic, solid rock plates of the lithosphere above it to slide around. Now, we're talking about really slow movement here, usually just a few centimeters a year, but the consequences of this movement are, frankly, monumental.
Section 2. Tectonic plates in action.
Okay, there are 3 main types of plate boundaries you really need to remember. The crucial point here is that the direction of the movement creates totally different geographical features. First, convergent boundaries. That's where plates crash into each other, folding the Earth up into towering mountains. Think the Himalayas. Second are divergent boundaries, where plates pull apart, letting magma rise up to form brand new crust, like mid-ocean ridges. And third, transform boundaries. That's where plates grind and side past each other. This friction doesn't create or destroy crust, but it causes violent earthquakes. You know what's fascinating? How long humans have been trying to figure this all out. Ancient Indian texts, like the Brihat Samhita, were already blending careful observations of nature with early attempts to understand these immense, earth-shaking forces. Brilliant thinkers like Varamihira looked at wind, fire, heaven, and water to try and explain why the ground would suddenly violently shake. And the reality of those internal movements can be absolutely devastating. We saw this firsthand right here in India during the 2001 Gujarat earthquake. When those tectonic plates suddenly slip, the energy released can cause immense tragedy. And this is exactly why studying this geography chapter isn't just about, memorizing facts. Understanding fault lines is absolutely critical for modern disaster management and, ultimately, saving lives. But hey, plate movement doesn't just mean destruction. It also creates incredible, super rare natural wonders. For example, over in the Andaman and Nicobar Islands, you can find the Baratong Island mud volcano. So instead of a fiery lava eruption, underground gases and intense pressure push bubbling mud right up to the surface. It is a spectacular reminder of that active engine rumbling right beneath us. Section 3. Nature's slow sculptures. Let's talk about weathering and erosion. Now pay close attention here, CMSHI and a Colony students, because this is a classic exam question for sure. You absolutely must know the difference between weathering and erosion. Notice the distinction here. Weathering is simply the breaking down of rocks into smaller pieces. There is no movement involved. Erosion, on the other hand, is the wearing away and the transportation of those materials. Basically, erosion is the delivery system carrying all that debris away. Let's break down weathering real quick. It happens in 3 main ways. Physical weathering is when temperature changes or frost literally crack the rock apart. Chemical weathering happens when minerals in the rock react with water or air, completely changing their composition. And biological weathering, that's when nature fights back, like when plant roots grow right into the cracks of a solid rock and just split it wide open. This is exactly how entire mountains are slowly turned into the foundational materials we need to eventually create soil.
Section 4. Agents of Gradation. The forces that shape our world. So what's actually doing the heavy lifting here? Natural forces, which we call agents of gradation. We're talking about running water, wind, crashing ocean waves, and colossal glaciers. Over thousands, even millions of years, they wear down the high places, transport the rocks and soil, and deposit them in lower places, effectively smoothing and leveling out the surface of our entire planet. Let's see how this works with a river. In its upper course, coming down a steep mountain, a river has aggressive, fast-moving energy. It literally acts like a saw blade, cutting deep, V-shaped valleys right through solid rock. But later, as it reaches the flat plains, it loses that energy and starts depositing all that sediment, which forms rich, fertile deltas.
Higher up in the freezing altitudes, the main agent of gradation is ice. Moving ice, in the form of glaciers, acts like a giant, slow-motion bulldozer. As a glacier slides down a mountain, it scrapes the earth, carrying gigantic boulders with it and deeply carving out peaks and valleys. It leaves behind these absolutely stunning panoramas.
Section 5. Humans and the land. How we adapt to the earth.
Because erosion can literally wash away vital farming topsoil, humans have had to adapt. Some truly ingenious ancient practices were invented to protect our land. Texts like the Arthashastra outlined incredible agricultural planning, and we see amazing practical examples, like the Zabo system in Nagaland, which uses earthen bunds on hillsides to catch water and stop soil from washing away. Techniques like contouring, bunding, and terracing actually step the land so that water slows down, saving the precious soil that feeds us all. You know, people often say that geography is destiny. Remember that the physical features carved by these forces have literally shaped the rise and fall of whole civilizations. The Himalayas, pushed up by tectonic plates crashing together, have acted as a formidable protective wall for India. Meanwhile, the fertile plains created by river erosion and deposition, like those of the mighty Ganga, well, they became the cradle for agricultural societies, feeding millions of people and allowing our cultures to absolutely thrive. So I'm going to leave you all with this provocative thought. You started today wondering if the ground beneath your school was moving. Now that you understand the powerful tectonic engine beneath us and the slow sculptors of weather and water above us, how will you use this knowledge? Think about your own local geography. What landform disasters, like floods or earthquakes, should your community prepare for today? Because geography isn't just about maps, guys. It's about our survival and our future. Keep exploring, keep questioning, and hey, I hope this helps you absolutely ace your upcoming exams.